Good afternoon, students. Today we are going to be talking about lesson 27, connecting the parabola with the quadratic function. So of course, before we go to quadratic functions, we need to take a look back at where you've been, and that would be talking about linear functions. Now we know a linear function is a direct relationship between the x, y variable. You might recognize these looking at the form there, f of x or y equals mx plus b, where m and b are real numbers. When we graph those, we get nice straight lines. But of course, we can manipulate our variable, and that comes with our exponents. So we can get them to a quadratic function. And a quadratic function, you'll notice we now have a squared there by our x. So our quadratic function f of x equals ax squared plus bx plus c, where a is not equal to 0. So that means our x squared term is there. And then a, b, and c are real numbers. And that ax squared plus bx plus c, that is our standard form for a quadratic function. So we have either f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. Now, some problems in this chapter might ask you to rearrange a function into that standard form. So we have an example here that we're going to go through. We have 4 times the quantity x minus 1 squared plus 3x plus 2. So we're going to do a little bit of algebra here to rearrange this and get it back into standard form. We're going to, of course, square our x minus 1. Your order of operations says exponents come first, so we're going to have to do some FOILing there for that x minus 1 squared. X times x gives us x squared. X times negative 1, that's a negative x. Negative 1 times x, that's another negative x. And negative 1 times negative 1 plus 1. So that would be x squared minus 2x plus 1. We'll bring down our 4. So we have 4 times the quantity x squared minus x plus 1. And then bring down our 3x, bring down our plus 2. We're going to now distribute that 4 through. So we'd have 4x squared minus 8x plus 4. The 4 gets distributed to each term. Now we have plus our 3x plus our 2. And of course, we begin to then combine like terms. We're going to have our 4x squared minus 8x plus 3x. That gives us minus 5x plus 4 plus 2 plus 6. So f of x is equal to 4x squared minus 5x plus 6. There it is in standard form. So just a little bit of algebra there to kind of go through the process and help you rearrange it. Here's another one for you guys. Come on, paper. Yeah, so please rearrange the following to put it into standard form. You have the equation, or the function f of x is equal to negative 2 times the quantity x plus 3 squared minus 4x plus 6. Go ahead and rearrange that on your own, and then you're going to need to submit it. And we will be checking that and talking about it first thing tomorrow. All right, so one of the reasons that it is important to get it into standard form is that standard form makes it a lot easier to graph. If it's in standard form, then we can easily put in our values for x's and y's and get data points that we can then use on a graph. So we have another quadratic function there. F of x is equal to x squared plus 2x minus 2. And we want to put in some values here in our data table and get some points and then graph this. So let's start with at x of negative 3. And we'll go negative 3, negative 2, negative 1, 0, 1, 2, and 3. So let's kind of work through these. So we put in negative 3 for x squared. So we'd have negative 3 squared plus 2 times negative 3 minus 2. Negative 3 squared, 9. 2 times negative 3, that's minus 6. And we minus 2 there, and we get an answer of 1. Okay. Sorry about that. Next, we'll do it with the negative 2. So negative 2 squared is 4. 2 times negative 2 is negative 4 minus 2. So we get a value of negative 2. Putting in negative 1 squared is 1. 2 times negative 1, that's minus 2. And then our minus 2, we get a minus 3. Putting in 0, we get 0 plus 0, minus 2. Putting in a value of positive 1, 1 squared is 1, plus 2 times 1 is 2, minus 2. So we get a value of 2. Putting in 2, 2 squared is 4. 2 times 2 is 4, minus 2. So we have a value of 6. And then 3 squared is 9, plus 2 times 3 is 6, minus 2. That gives us a value of 13. So we have some data points there. We can now put those into a graph, and we can figure out and see what it comes out to be. So I got a graph here. Our first point, negative 3 and 1. So we have x of negative 3, y of 1. Our second point, negative 2, negative 2. Negative 2 and negative 2. Our third point, negative 1, negative 3. Then we have 0 and negative 2. 1 and 1. 2 and 6, and that's actually off my graph paper. But we can see here from our points that we have the basis of a parabola. And hopefully you remember what a parabola looks like. I'm going to put in a better graph of that. Thank you, Desmos. And as we see, it's kind of our U-shaped graph where we still have our points that were there. We had our negative 3, negative 2, or negative 3 and 1, negative 2, negative 2, negative 1 and negative 3, 0 and negative 2, and then 1 and 1. There are our points. And when we get it, we have that nice curve that goes through it. Now, on that curve, we can identify a couple key points. The first key point is called a vertex. The vertex is defined as the highest or lowest point of the parabola. That depends if the parabola opens upward or opens downward. Here, with a downward facing parabola, our vertex is at the top, so that would be the highest point. And here, with an upward facing parabola, our vertex is going to be the lowest point. So back on our graph here, this lowest point right here, this would be our vertex. And the point would be negative 1, negative 3. The second thing we want to identify in a graph are the zeros. Zeros would be where the function crosses the x-axis, or where f of x is equal to 0. So we want to look at our parabola and look across the x-axis and figure out where it crosses those lines. We have 2 zeros in this parabola because it crosses the x-axis twice. It's also possible for a parabola to have 1 0, where that vertex would be the only point on the x-axis, or it's possible for a parabola to have no zeros. If the parabola is entirely above the x-axis, there is no point where it crosses the x-axis, so we would have no zeros. So, looking back at our graph, we would have 2 zeros, 1 there, and 1 there. And of course, with graphing software, we can click on those points and get values, or we could always try and solve the function. We could say 0 equals x squared plus 2x minus 2, and work through it and find the 2 values of x that would satisfy that function or that equation. There's one last thing when talking about a graph. Parabolas also have what's called a line of symmetry. All parabolas have a line of symmetry that passes through the vertex. Now, we can find the mathematical coordinate of the vertex by looking at that basic or that standard form, that ax squared plus bx plus c. It turns out that the x value of that line of symmetry, or the vertex, can be found by taking negative b over 2a. If we look back at our graph here, a would be our term for our x squared, so that's 1. B is our term for our x, so that's 2. And if we say x equals negative b over 2a, we would have negative 2 over 2 times 1. So negative 2 over 2, which would be equal to negative 1. And if we look up here at our vertex, our x point is negative 1. If we put that negative 1 into our equation, then we'd have negative 1 squared plus